Hello everyone. Okay, so in this video we are looking at inverse functions. So what is an inverse function? So an inverse function is a mapping from my outputs back to my domain. So we're just doing the opposite. So here's my function f. We see here 1 maps to x, 2 maps to z, 3 maps to y. But an inverse function would flip that and say, well, x mapped to 1. It just goes backwards. Y maps to 3 and z maps to 2. So the thing about an inverse function is we are able to find our original input given our output. Now, inverse functions only work if a function is bijective. So if a function is bijective, an inverse function does exist. So how to find an inverse function? So you write the function in the form y equals blah, 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 blah. Then you isolate and solve for x. Now, when we get to quadratic functions, we have to complete the square. And then once we have our x on its own, we replace x with f to the power of minus 1x and replace y with x. I'll show you now in a minute. Find the inverse function of 2x plus 3. So we rewrite it as step 1, y equals 2x plus 3. It's going to be y minus 3 equals 2x. Now we're rearranging and solving for x. Divide both sides by 2. I get x is equal to y minus 3 all over 2. And the final step is I replace x with y with x. It'll be x minus 3 all over 2 is equal to my inverse function. So to test it, just try 2 points. So what's f of 1? F of 1 is going to be 2 times 1 plus 3, which is equal to 5. So my input's 1, my output's 5. Now let's test my inverse function. So if I put in f of 5, I should get back out 1. It's going to be 5 minus 3 all over 2. It's 2 over 2, which is 1. So therefore, this inverse function works. Right? Now, with a quadratic function, we have to complete the square first. We can't just get x on its own. So I have y equals x squared minus 4x minus 4. So complete the square. So take out a factor of factor out the coefficient of x squared. In this case it's 1, so I don't have 1. Divide by minus 4 divided by 2 squared, which is minus 2 squared, which is equal to 4. Then what I do is I plus and minus 4. So it's x squared minus 4x plus 4 minus 4, and then we subtract 4 again. This is a perfect square and can be written as x minus 2 squared. Minus 4 times minus 4. Minus 4 minus 4 is minus 8. Now we get x on its own. So it's going to be y plus 8 equals x minus 2 squared. Square root both sides. I'm going to get x minus 2 is equal to square root of y plus 8. X equals square root of y plus 8 plus 2. And then last step, rewrite it as f of inverse x equals root x plus 8 plus 2. There is my inverse function. So it's for a domain of 2. So let's test it out. So let me just test f of 3. I test f of 3, I'm going to get 3 squared minus 4 times 3 minus 4, which is 9 minus 12, which is minus 3. So it's going to be minus 7. So 3 minus 7. So if I put minus 7 into my inverse function, I should get 3. So it's going to be minus 7 plus 8 plus 2, which is equal to 1 plus 2, which is equal to 1 plus 2, which is equal to 3. So therefore, my in. Right. So let's just look at these exam questions. So this came up in 2016. Show that f of x at 3x minus 2 is an injective function. Well, it's an injective function because it's a linear function. It's a line, right? Ding, ding, ding. So as it is linear, it is injective. Given that f of x equals 3x minus 2, find the formula for the inverse of x. So that is just y equals 3x minus 2. Y plus 2 all over 3 is equal to x. Change it around, x plus 2 over 3 is equal to f inverse of x. That's it there. Right. This one now, my function is now 2 to the power of x. So I have y is equal 2 to the power of x. So I want to get x on its own. So I'm going to have to use logs, right? So it's going to be log base 2 of y is equal to x. So 2 to the power of x gives me y. So remember, BAP, base, answer, power. Base, answer, power, BAP, right? So log base 2 y is equal to x, and then as the inverse, that is going to be log base 2 of x equals f inverse of x. Funny. Verify that the composite function of inverse of h of x, equals h inverse of the composite of h inverse of x in h of x. So that is going to be h inverse of h of x, which is 2, 3x, is equal h of my inverse, which is log base 2 of x. So that is going to be log base 2 of 2, 3x equals 2 to the power of log base 2x. That is going to be now this side here. Using my rules of logs, I can write this as x log base 2 is equal to 2 to the power of log base 2 of x. This is just going to be equal to x. And then 2 to the power of log base 2 of x. Well, log is just an inverse function. So this will just equal to x. So I've proven that it's equal to x there. Because because this is essentially now 2 to the power of what will give me x. So this just means 2 to that specific power has to give me x. So these will cancel out. So I get x is equal to. Right, this one here. G of x equals 3x. H of x equals 1 over x. Find inverse of g, inverse of h, and then the composite of functions g and h. So y equals 3x. X over 3 equals the inverse of g. Y equals 1 over x. The inverse is actually still going to be 1 over x of h. And finally, find g of h of x. So that's going to be g of 1 over x, which is equal to 3 times 1 over x. Okay. Show that the inverse of h of g of x is equal to the inverse of h plugged into the inverse of g. So what's the inverse of this? So I have h of g of x equal to h of 3x, which is equal to 1 over 3x. So that is equal to y. So that is going to be 1 over 3x is equal to inverse of 1, or the inverse of that function, because the multiplier across by x divided by y. So I'm back to kind of where I started. So the inverse of h of g of x, that. Then I want to find now the inverse of g, the inverse of h plugged into the inverse of g. So g inverse of h inverse, which is 1 over x, which is equal to 1 over x all over 3, which is just equal to 1 over 3x. Therefore, they are the same. Then if h of x equals this, find h of inverse of x. So I have a quadratic. I need to find the inverse. So complete the square. So don't need to factor in x squared. So it's going to be 2 divided by 2 squared, which is 1 squared, which is 1. Which is going to be x squared plus 2x plus 1. Plus 1 minus 3 minus 1 is equal to y. This is the perfect square. X plus 1 squared minus 4 is equal to y. X plus 1 squared is equal to y plus 4. X plus 1 is equal to the square root of y plus 4. X is equal to the square root of y plus 4 minus 1. Therefore, my inverse function is f of minus 1x is equal to root x plus 4 minus 1. There you go. That is how we find inverse functions. So, next step is how do we sketch an inverse? So, when asked to sketch inverse of a graph, follow these steps. So you have to draw the line y equals x, okay? Then use the line as a reference for reflecting the function. So you reflect key points. So you find some key points on the graph and you reflect them. So if the point was AB, you reflect it to be BA. So you swap the coordinates. Then you sketch the reflected points and then try and draw a smooth curve. So, for example, we want to reflect this one here. There's 2 key points, 2, 4, 1, 1. So the reflected points will be 4, 2, and still be 1, 1. So 4, 2 is here. So I need to kind of, and then 0, 0, so be kind of like that. A 0, 0 is also another key point here. Be like that. That is going to be my f of inverse, right? So I plot 4, 2. My 1, 1 still there. You kind of draw a curve and match the shape. So let's have a look at this one here. Parts of the graph of the function h of x equals x and k of x equals x cubed. Find the coordinates at the point of intersection of the 2 graphs. So I need to find where these intersect. So I let them equal each other. So I have x cubed minus x equals 0. Factor out an x. I'm left with x squared minus 1. This is going to be x times, this is the difference of 2 squares, f plus 1, f minus 1 equals 0. Therefore, it's x equals 0, x equals minus 1, and x equals 1. So it's asking for the point of intersection. So it is going to be, so if my function is just x, this is going to be 0, 0, minus 1, and 1, 1. If my function h of x is just x. Fine. On the diagram, using symmetry or otherwise, draw the inverse of k of minus 1. So I have key points here. So this is minus 1, minus 1. This is 0, 0. And this is 1, 1. So we kind of need to flip these around. But they actually don't need to flip these around much. So it's here, here, here. But we're kind of reflecting other key points. So like say this point here would be over here. You know, this point here, A1, would be like here. So my new curve is actually going to be like that. That is what my new curve is going to look like. So I had 3 points there, but I focus on a few other points just to kind of get the general shape of it. Right. And that's it on inverses. I hope this video some helped you guys, and I'll catch you guys later. Bye.